Here at the Texas Instruments here at the Embedded World, showing off the Smart Factory Industry 4.0. Hello, so who are you?
Hello, my name is Frank Walzer. I'm from our industrial application team, and I'm going to explain you the Industrial Industry 4.0 wall, where we show different products from Texas Instruments, starting with some of the analog components that we have for temperature measurement.
What is this one?
This is a 4 to 20 milliamp sensor connecting to an EtherCAT gateway. Here we have a temperature and humidity sensor. It has also 40 to 20 milliamp, but also a Bluetooth interface. Then we have other industrial sensors that are connecting through IO-Link, which is another standard in the industrial communication area.
What are we looking at here? What is this one, sorry?
This is the PLC that's collecting the data through the EtherCAT interface. It's running a Codesys PLC software.
What is this chip?
The chip is the AM5728. It's the dual Cortex A15 microprocessor running at up to 1.5 gigahertz. So very high performance.
And that's the very popular choice in the industry?
Yes, now it runs Linux and you can implement a complete PLC on top of that. So here we run directly, it drives the HDMI monitor and the graphics. And as I said, it's collecting the data and showing them here in a graphical representation. On the other side, we can control our motors using the C2000 and the AMIC 110 parts to again interface with EtherCAT and then drive a brushless DC motor directly using our newest driver technology, gallium arsenide.
You have gallium arsenide to do what?
It's an efficient, high-performance driver chip with special technology that you can't do in silicon semiconductors.
So is the next thing after silicon is going to be the gallium valley?
For certain areas, yes, I would say so.
But for any kind of chip, or only some kind of chip?
It doesn't apply to everything.
Some chip.
Specific. And here we have what we call a resolver and encoder interface. And again, we use the C2000 DSP to encode the data, send it to EtherCAT, and it's shown over here on the display. So if I turn that, okay.
Cool. So that's the Industry 4.0. It means, what does it mean? It means it's higher integration?
No, it's communication in the industry world now, and it's a new approach to bring the data together into the technology in the cloud and into a higher environment, not just in the single machine, but factory and then higher in the whole ecosystem of the customers.
Cool. And what else are you showing around here at the booth? Can we go over there?
Yes, sure.
Let's go there.
We go to the power management.
Let's check it out. Hi, so who are you?
Martina, hi.
Okay.
And can we change
Yeah.
this? Sorry.
Let me go around here.
Let's go.
Yeah. Let me go around here. So here we're looking at some power management. Sorry, I jump in. Hey.
Sorry?
Can you show what is going on here?
Yeah, I'm not so familiar with this because this is not my demo, but I can tell you 2 or 3 sentences of this.
Okay.
So this is a buck controller. Input voltage is 12 volt. Output voltage here is 1 volt. Here you can see this controller has 4 phases. We have here active phase shedding, means for the minimum output load just 1 phase is active, and for the maximum output load all 4 phases are active.
So this is a special way to do power control or power management, or what is it?
Yeah, this is a buck controller with an integrated power management bus. The maximum current here is 120 ampere. What you see here is a load step between 10 ampere and 60 ampere. And the green output voltage here shows the voltage variation during a load step.
All right.
10 to 60 ampere.
Cool. So is a TI a leader in this kind of field to do all kinds of power management? As TI is a leader?
Yes.
Power management IC, right?
Yes.
It's everywhere, in
IC.
everything.
Yeah.
It's in laptops, phones.
Power management is everywhere.
And this is the next gen or special way to do power management.
Yeah, this is a special way, but we, our group, are developing a lot of power supplies for all application segments.
All right. Cool.
Okay,
Thanks a lot.
good. Yeah, you're
Thanks.
welcome.
I'm gonna check around here. What's going on with the Simple Link?
And then we kind of go to the higher end.
Simple Link right here. Sorry, I'm just jumping in. Sorry. No, okay. So right here, yeah. And then I'll go around here. I'm just checking here. There's a special display. And then I'll go around here.
But if you're around,
Mijn gsm-nummer is nog nooit veranderd, dus...
Hey, can I ask you what you're showing here? Not just now. Okay, right here is a whole bunch of boards. But I'm gonna go check them out at the Beagle. Lots of different boards right here. MSP 430. Okay, no problem. I'll jump out. No problem. Okay. And then I'll go right here. It's also single chain. Hey, how are you? Can I ask you about this?
Sure.
All right. So we here at the. This is single. What are we looking at here?
Well, that is signal chain. And we have some demos here which are mainly around inductive sensing.
So it's sensors.
Sensors, well, we don't do a lot of sensors. We do a lot of sensing. So sensor would mean that you have something which measures a physical effect directly.
All right.
Like we have, for example, a humidity sensor. So
This one.
here, that's a little IC which senses humidity and temperature. That is what I would call a sensor. Now this is more sensing. So it senses a rotational movement.
All right.
Or it senses events when these fans here pass by. Or it senses this position. Now, this is a sensor because this is also part of the sensor.
All right. So you do IC. It's all about IC.
It's
right?
all about ICs, yes.
And there's a lot of it from TI in the world, everywhere.
Yes.
It's in everything, and it's enabling all these sensors. If you're not doing the sensor, you're enabling it. You're doing all the calculations.
We are measuring what comes out of the sensor, and we provide that to the computer.
Cool.